All right. Hi, everybody. So, a reminder again, sorry that I'm out today. I had jury duty. So, today we're going to talk about complex and imaginary numbers. Okay. Yesterday we reviewed the fact that I is equal to the square root of -1, and we worked with square roots. So, today's video is going to be about how to graph these things called complex numbers, and then a little bit of properties about I. Okay. So, a complex number is any number that can be written in the form of a plus bi. Okay, so it has two parts. It has the real part and the imaginary part. Okay, that's why it's called complex because it's not just a number. It's a number and then an imaginary part. Okay, so for example, 3 plus I, that's a complex number. 4 plus 2i, complex number. 5 minus I, complex number. Okay, so technically it should be plus or minus bi. All right, so I'm going to scroll down just a little bit. Okay, and so now let's talk about, well, how do we graph this? All right, and so the x-axis is going to be the real component, and the y is going to be our imaginary piece. So how can I represent 5 plus I? I just go 5 to the right. And then the number coefficient in front of I is a 1 because it's really 5 plus 1i. And so I'm going to go up 1, and this red dot represents that. Okay, so now let's just quickly blow through the next ones. I got -2 minus I, so left 2 and down 1. So that's A. B is -6 and plus 3, so left 6, then up 3i. And this would be point B. 5 plus 4i, so go right 5 and up 4, part C. And D is right 1 and down 3, and that's part D. Okay, so there's how you're kind of plotting these coordinate points, or these complex numbers, I should say. Okay, so scrolling down again. All right. Oop, sorry about that. And now working backwards is just kind of saying, okay, A is 2 to the right and 3 up, so 2 plus 3i. And now pause the video and try B, C, D, and E. Okay, so if we take a look, B is left 3 and up 1, so -3 plus I, or plus 1i, same thing. C, we didn't go left or right at all, so it should be 0 plus 2i. D should be 1, 2, 2 to the left and down 5, so -2 minus 5i. And E should be right 1 and down 4, so 1 minus 4i. So that's graphing in a nutshell, right? You got a real part and an imaginary part. Okay. All right. Now it comes for the harder stuff. All right. So we're going to do some problems where when we do some algebra steps with them, you're going to get powers of I. Okay, you're going to get I to the third. You're going to get I squared, I to the 40th, whatever. Okay, and there's a strong pattern to it. Okay, it can only be one of these four answers: I to the 0, I to the 1, I to the second, and I to the third. Now, I like this visual of the circle because it's going to be one of these four. All right, especially since it's like the four quadrants and tied together with the 4 component, we can take whatever exponent we have and divide it by 4. The remainder are 0, 1, 2, or 3. And the good news is we know everything about this already. Okay, so I to the 0, anything to the exponent power of 0 is the number 1. Anything to 1 is that thing itself, so it's I. Now, we talked about I being the square root of -1. I squared, if I squared this, the square root and squared go away, I'm left with -1, and this one is -I. All right, so keep in mind this chart you are eventually going to have to know, but the good news is you can reason your way through 3 of the 4. This one's a little bit tougher, but the first 3, if you just kind of understand exponent properties a little bit, your answers are 1, I, -1, or -I. All right, so let's go through an example together. Let me scroll down first. All right, scroll down and let's take a look. So I'm just going to do the math off to the side. If I go 100 divided by 4, because it's a rotation of 4 answers, okay, it is even 25 with no remainder. So this is the same answer as I to the 0 would be. Well, what is I to the 0? 1, and my final answer is 1. Now let's show you one with a remainder. 65. Okay, 65 divided by 4. It's 64. 16, not 64. It goes in 16 times, and with a remainder of 1. Okay, so this is going to behave like I to the first. Well, what is I to the first? It's I. All right, so when we do, like, we haven't done the math problems yet where we get I to the 65th. That's like an answer to a different problem. Then we got to simplify them. Okay, so let's go I to the 11. Well, if I divide 11 by 4, it goes in 8 times, so it's 8, remainder 3. So this behaves like I to the third, which is negative I from that circle above. And so we're going to look at these exponents and we're going to simplify them. Okay. All right, let me clear this off and we'll keep going. 44 divided by 4. There is no remainder because it's 11 clean. So it's I to the 0, which comes out to be 1. Then 15 divided by 4. Well, it goes in to 12, so a remainder of 3. So it's I to the 3, which is negative I. And 21 divided by 4, it goes in 20 to 20, and there's a remainder of 1. So it's I to the first, which is just I. Now it's all about those remainders, 0, 1, 2, or 3. All right. So divide 6 by 4, it's a remainder of 2. So I squared is equal to negative 1. 8 divided by 4 is 0. So I to the 0 is 1. 14 divided by 4 gets me to 12. And then remainder of 1. So I to the 1, which is just I. Okay. If you divide the exponents by 4, every single exponent or answer that you will get will either be I to the 0, I to the 1, I squared, or I to the third. And this is equal to 1, I, negative 1, negative I. Okay, so just take a look and we'll talk more when I get back. All right, thanks guys.